Most telescopes on Earth spend their time unveiling the mysteries of the universe. But some, like the European Space Agency Teide Observatory on the Canary Islands, are used to search, track, identify and catalogue less glorious aspects of space exploration.
We are here in the Teide Observatory, and this one is a space debris telescope. We use it to track high-altitude debris from by geosynchronous orbits or any orbit which is crossing the geosynchronous orbit.
In these distant orbits, some 36,000 kilometers from the ground, not all objects are operational geostationary satellites.
What you see here are the stars. They make trails like that. Anything else, for example, a comet or some other object which would not be circulating Earth, would make a trail like that. And this particle here is a debris particle. And you can see that it hasn't moved at all in our field of view compared to the stars, because we were following the debris itself. So lucky guess would be around 40 centimeter piece.
The ESA facility in the Canaries can detect objects as small as 10 to 15 centimeters. Its observations, together with others, complement the catalogue of all objects larger than a meter, which is maintained by the United States Space Surveillance Network. Over the past 50 years, mankind has, it must be admitted, left a lot of pollution in space.
Space debris can, for instance, be satellites which are not operational anymore. This can be upper stages which have delivered the satellites into their orbits. This can be what is called mission-related objects, objects which are necessary to deploy a mission in orbit, but again, which do not fulfill a useful purpose on their own. And then there are an awful lot of fragments from explosion events and also of some collision events. And in fact, these fragments make up more than 40% of what we know of in space.
The vast majority of the space debris are in low Earth orbits, up to some 2,000 kilometers, and moving at considerable speeds of up to 28,000 kilometers an hour. For their observation, powerful radars are brought into action, like the Afghan facility with its 34-meter antenna at Wartburg near Bonn.
We have two radars mounted in this big antenna. One is for tracking the object, for finding out the position, and the other radar is for imaging the object, so we can have images, pictures, and even radar films of the object, as you might see here. Yes. The goal of those measurements is to provide the agencies with data by which they can verify the models they are building for statistical description of the population. For example, ESA's master model, which has to be calibrated by those snapshot measurements which we do mainly by radars in low Earth orbits.
With these data, ESA can advise missions on crowded orbits. It can predict possible hazards and determine risks of collisions for operational satellites, or for manned missions so that the necessary avoidance measures can be executed. Impacts from debris could have catastrophic consequences both to the satellites and to the environment.
The shield of the International Space Station, which protects the manned modules, is able to defeat objects of about 1 centimeter in size. This is an aluminum sphere of 1.2 centimeter diameter. And this aluminum sphere was fired at a solid aluminum block at a velocity of 26,000 kilometers an hour. And if you do this, then this tiny object here will cause such a crater. So what one tries to do is improve the shields in order to increase the shielding capability from 1 centimeter upwards. And the other thing is we try to improve the observations to reduce the tracking threshold from 10 centimeters further down. So there is 3 centimeters of gray area that we are not very certain about right now.
Ever since the accidental explosion in 1986 of a spent Ariane upper stage, European launch operators have taken steps to passivate rocket stages, emptying their residual fuels to avoid explosions. But unfortunately, the problem of space debris is not fully appreciated by all. In January 2007, the Chinese deliberately destroyed one of their satellites by a missile impact.
We had one devastating collision at the beginning of this year, which alone cost on the order of 2,000 known objects. Today, 20 to 30% of all high-risk events, high-risk flyby events our satellites encounter are due to this Chinese anti-satellite test.
To date, some 12,500 space objects larger than 5 to 10 centimeters are contained in the US catalogue. But that is just the tip of the iceberg. It is estimated that more than 500,000 items larger than a centimeter are drifting in orbit around the Earth.